If two fed die are tossed once, find the probability of obtaining A said the same numbers, B is even or odd, even pair or odd pair. Now, when you toss two die, a die has six outcomes. When you get a die, it has six outcomes, 1 to 6. So two die, this is for the first die, this is for the second die. Now this shows the combination of these two dice. When you combine one and one, 1 and 2, that is 1 comma 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Start with 2 and 1. That is how you keep on combining them until you get all the possible outcomes needed. Easy, right? Okay, now the first question said, find the probability of obtaining the same numbers. Now you want the same number pair. Now look at it is easy because you can easily identify that the diagonal here is showing the same number. So you count how many there are. So have 1, 2, 3, 4, 5, and 6. So for A, probability of same number pair, let me say P, same number, is going to be equal to, remember that probability is the required outcome, and we counted 6 same numbers. The total outcomes here, the sample space, when you count them, it is 6 by 6, which is going to give us a 36. So have 36. When you reduce this to the lowest term, you're going to have 1 over 6. And that is the answer for A. B said, probability of obtaining an even pair or odd pair. Pair means just like this is a pair now, 1 comma 2. This is, sorry, 1 comma 1 is a pair. You want an even pair. Let's start with the even pair. Okay, for the even pair, that is a pair that is an even number. Okay, the first row is not going to start because 1 is an odd number. So this is an even pair. This is 1, 2, 3. Okay, since there's an odd number here, you leave it and come down here. 4, 5, 6. There's an odd number here, so you leave it, come down here. 7, 8, 9. So for the B, probability of even pair or odd pair. We need to get the one for the even pair. Remember that when you see or in probabilities, it is talking about the addition law. So we're going to have the one for the even pair, then we add it to the one for the odd pair. So for the even pair, that is P even pair plus probability of odd pair. Okay, for the even pair, we counted it to be 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So having 9 over the required outcome there is even pair. So I have 9 even pairs over total outcome is the total events, which is 36. Plus, now let's count the odd pairs, the one that are odd numbers. So we're going to have, this is, let me be circling it, 1, 2, 3 here. Since there's an even number here, we're going to leave it because the even number is not going to form an odd pair. So 4, 5, 6. 4 is an even number, so we're going to leave there, come here. 7, 8, 9. 6 is also an even number, you leave it as well. So the odd pair we're having there is the same amount, just like the even pair. So which is still, because if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 over 36. Since you have the same denominator, just go ahead and add your numerators, which is 18 over 36. When you reduce this to the lowest term, you're having 1 over 2. And that is the final result. Bye.